Let's look at the code which we'll need to write in order to create an alarm system with an ultrasonic device. We'll create 3 global variables: a trigger pin at pin 2, an echo pin, pin 4, and a buzzer pin at pin 6. The setup function is called when the reset button is pressed on the Arduino. The set mode sets whether a particular pin is an input or an output pin. The trigger pin, because it's sending a signal out, is going to be an output pin. The echo pin, because it will be receiving a signal back, is an input pin. The buzzer pin is set to output, because that's how we're going to turn the buzzer on and off. The serial begin is for communication. The USD find distance function takes 2 parameters, an int value for the trigger pin and an int value for the echo pin. It returns a double value. 2 local variables are also defined, an unsigned long for the pulse sent and for the pulse received. There's also a double value that's going to compute the difference between the time of the pulse received and the pulse sent, and a variable, distance cm, which will hold the distance in centimeters. A call is made to the digital write function. It takes 2 arguments, the trigger pin and high. So we're sending a signal out from the ultrasonic device. We'll put a delay of 1 millisecond. Then we'll call digital write a second time on the trigger pin and set it to low. Now we'll need to actually write a while loop, which will continue to use a digital read on the echo pin to see whether it's still low. And in this case, we'll delay for 0.1 milliseconds. This is going to indicate the time when the pulse is sent. The pulse sent is computed by calling the millis function. The millis function is the number of milliseconds that have elapsed since the time the device has been powered on. We'll then use another while loop and continue to use a digital read on the echo pin and see as long as it's high, we'll again delay or wait 0.1 milliseconds. Once the signal drops back to low, then that's the time of the pulse received. The sent received difference is going to be the time for the pulse received minus the pulse sent divided by 1,000 in order to determine the number of seconds that it took from the time the pulse was sent until it was received back. In order to compute the distance in centimeters, we're going to actually make use of the fact that the speed of sound is 343 meters per second. The distance in centimeters is computed by multiplying the sent received diff by 343, that's the speed of sound in air, times 100, because we want to find the distance in centimeters, and divided by 2.0, since we have to take into account that the sound wave was sent and then reflected back. Finally, we'll return the distance. The loop function is continually called as long as the Arduino device has power. The first command in the loop function calls the USD distance function and passes in the trigger pin and the echo pin. The return value of the distance in centimeters is stored in the local variable distance. We'll then print out to serial output the distance. We'll also declare another double value, distance inches. We'll compute the distance in inches as the distance divided by 2.54. We'll then also print out the distance in inches. We'll put a delay of 10 milliseconds before checking what the distance is. If the distance is less than 20 centimeters, we will call the digital write function, passing in the buzzer pin as one argument and high as the second argument. We'll put a delay of 1,000 milliseconds, so that'll turn on the buzzer for 1 second, and then we'll call digital write again, passing in the buzzer pin and low to turn off the buzzer. Once you've completed your code, you'll want to select Sketch and then Verify/Compile. This will compile your code and allow you to see if you have any syntax errors. You'll need to correct those syntax errors before you proceed to the next step. Select File and Upload to upload the sketch to the Arduino. Once you've uploaded the code, select Tools and Serial Monitor. you see an example of the distances in centimeters and inches that were recorded. And you'll notice that there is a blank line which indicates that I had actually placed my hand in front of the ultrasonic device at a distance that was closer than 20 centimeters. Let's look at the components you'll need to implement the ultrasonic alarm system. The ultrasonic device is shown here. This is a piezo buzzer. You'll need a half breadboard, some male-to-male jumper wires, an Arduino, and I'll be using the Arduino Uno, you'll need a USB-A to USB-B cable, and you'll need a power bank. Let's create the circuit. The ultrasonic device has 4 leads, a VCC, a trigger, an echo, and a ground. One lead is labeled VCC. That's what you'll connect to the 5-volt pin on the Arduino Uno. The next lead says TRIG. That's the trigger pin. That's going to be connected to pin 2 on the Arduino Uno. The echo lead will be connected to pin 4 on the Arduino Uno, and the last pin, the G and D pin, is going to be connected to one of the ground pins. So let's place this on our half breadboard. The ultrasonic device is positioned in pins A1 to A4. We're going to connect VCC to the 5-volt pin with one of our male-male jumpers. We'll plug this into E1, and then this will go into the 5-volt pin. The next pin we'll connect is the trigger pin. We'll plug that into E2, and that will go into pin 2. E3 will connect a male-male jumper wire to input 4. The last connection we'll make is to ground. So connect your male-male jumper wire from pin E4 to ground. Let's now connect the piezo buzzer. The piezo buzzer has a plus on one side. That's the anode. That's going to be connected to pin 6. The lead on the other side has no label. That's the cathode. That'll be connected to ground. Our anode is going to go into F30. Our cathode is going to go into F23. We're going to connect pin J30 to pin number 6 on the Arduino board. we're going to connect J23 to the ground pin. Now let's test this circuit. We're going to connect our cable to the power bank in order to power the Arduino Uno. Now the Arduino has the code already uploaded as a sketch. Now if I aim this up at the ceiling, you'll see that there's no signal. As soon as something passes in front of it, you'll notice that there's a beep. This is our completed circuit.